So today we're going to be talking about relations. Basically, when we say relations, we're talking about how does x and y relate. We're talking about graphs and tables, and we're going to be doing some mapping and ordered pairs as well. So the vocabulary for this lesson, we have coordinate plane, x-axis, y-axis, origin, ordered pair, domain, range, independent variable, and dependent variable. We're going to be on this slide. We're going to be covering from coordinate plane all the way down to range. We will be working with independent and dependent variable a little bit later on. But the first couple of vocab terms, it should come it should be like, this should be more of a refresher for you. So the coordinate plane, what we have off to the right, that is an example of a coordinate plane. A coordinate plane is formed by the intersection of two number lines of the horizontal axis, which is left and right, and the vertical axis, which is up and down. So the x-axis. The x-axis goes left and right. Goes left and right. That is our x-axis. Our y-axis is vertical. Please do not mix these two up. Alright, with the origin. The origin is right in the middle, right where the two lines intersect. This point is always labeled as 0, 0. Now what I wrote right there, that is what's called an ordered pair. The ordered pair tells you exactly which point on the coordinate plane you're looking at. So if I'm looking directly in the middle of the coordinate plane, I'm looking at 0, 0. When I'm looking at a point, to say that we have 1, 3. This is the very first number is always the x. The second number is always, where it's on the coordinate plane, the y. Just think of it as the alphabet. X always comes before y. So to find this point on the grid, we would go on the x-axis over to 1. Then on the y-axis, we will go up to 3. So 1, 3 is this point right here. 1, 3. Alright, when it comes to the domain, think of it as all numbers that are in the x. Any number that's on the x-axis is part of the domain. The range is always all the numbers that are on the y-axis. So domain is x, range is y. I'm going to show you a little bit more about what I mean in the next couple of slides. So let's say that we are given a couple of ordered pairs. We have 5 ordered pairs off to the left. And what they are wanting us to do is to put these ordered pairs into a table and into mapping. So all that we have to do, we just have to remember that the left side of the comma on the ordered pairs are the x's, and the right side of the comma are the y's. So all that we have to do is basically just take this ordered pair and transplant it up here into the table. So for example, if we have 1, 2, we have 1, 2, 4, 3, 7, 1, 2, 2, and 5, 6. That's basically all that we have to do to put the ordered pair into a table. Now with mapping may seem maybe a little bit new for you. So this is where the domain and the range come into play. So the domain, with mapping, you can tell that we have two boxes. This is the left box is going to be the x coordinates, the right box is going to be the y coordinates. Now remember, when it comes to the x coordinates, these are called the domain. And when it comes to the y coordinates, they are called the range. So whenever we see whatever numbers that we see in the domain or the x coordinates, all that we have to do is put these numbers in this mapping. You only have to put the number once. If it repeats, then you just have to put it in there once. So for the domain, all we have to do is put these numbers right in here. So we have 1, 4, 7, 2, and 5. They don't have to be in numerical order. That's fine with me. Now when it comes to the range, all we have to do is put these the y points in there. So we have 2, 3, 1, and if you notice, 2 is already repeating, so we don't have to put that in there, and followed by 6. Now we're not finished with the mapping yet, because it just shows that that these are all the numbers for x, these are all the numbers for y. But where does this one go to? Which domain pairs up with the range? So we have to draw arrows. So this 1 goes with the 2, this 4 goes with the 3, this 7 goes with the 1. So this 2 right here goes back up with the 2, and this 5 goes with the 6. So this is an example of mapping and of how to create a table. Alright, so now what I want you to do is to try this yourself. Pause the video, and I want you to put these ordered pairs into a table and in the mapping. Press play whenever you are finished to see what I did. Alright, so we have our ordered pairs. We have 2, 4, 9, 2, 1, 6, 2, 6, and 3, 1. So remember, all that we have in the left side of the ordered pair is x, all that we have on the right side of the ordered pair is y. So all that we have to do is transplant all these numbers up into the x's and all these numbers into the y. So we have 2, 4, 9, 2, 1, 6, 2, 6, and 3, 1. Alright, so that is a finished table. So if we go down to the mapping section, down to the mapping, remember the left side of the mapping is the domain, which are our x's, and the right side is our range, which is our y's. So all we have to do, take these numbers, put them into here, take the y numbers, put them into the range. So let's see here, we have 2, 9, 1, the 2 is already repeating, so we don't have to put that in there again, and 3. So now with the range, just put these numbers right in here, we have 4, 2, 6, the 6 is already repeating, so we don't have to put that in again, and 1. Now we're not finished yet. Remember, we still have to draw our arrows to see which one pairs up with each other. So this 2 goes with the 4, this 9 goes with the 2, this 1 goes with the 6, and then we have this 2 up here. It also goes with the 6, and this 3 goes with the 1. When it comes to real-world problems, you'll have two things. You'll have an independent variable and you'll have a dependent variable. So the independent variable is the variable that determines the output. The independent variable is always the domain. It is x. The independent variable is the domain. What also might help you is this part, it's the number that stays constant. So for example, you might have time. Time never changes, it always stays the exact same. So like for years might be an independent variable. Hours might be an independent variable. Now the dependent variable is the value that depends on the independent variable. The dependent variables are always the range. The range is y, so the dependent variables are always on the y-axis. It's for example, like the price of gas. Back in the day, the gas prices were lower, and due to inflation and other politics, the gas price has raised. So the price of gas is the dependent variable. So let's look at a real-world example. So in 1948, a movie ticket cost 36 cents. In 2006, the average ticket price in the United States was $6.50. I want to figure out what is the independent variable and the dependent variable. Remember, the independent variable does not change. It is constant. Remember, the dependent variable depends on the independent variable, and it can fluctuate. So, what is constant with the independent variable? So remember what I was saying, it was like time or hours. In this case, we have years. So one of the independent variables is 1948. And another one of them would be 2006. So the dependent variable, what would pair up with 1948? We're looking at the ticket cost. The ticket cost is what changes. So we have 36 cents and we have $6.50. If we write these as ordered pairs, remember we have the independent variable is always x. So if we have 1948 is our x variable and 36 cents is our y variable. So that's one ordered pair. Our second ordered pair is 2006 and $6.50. So what I want you to do now is to try the following example and figure out what the independent and dependent variable is. So pause the video and press play when you have finished. Alright, so we have Mike's cell phone is part of a family plan. If he uses more minutes than his share, then there are fewer minutes available for the rest of his family. So we have to remember that the independent variable is something that is not going to change. And the dependent variable is solely depends on the independent variable. So we have to think about what is going to be the independent variable, which for me is going to be how many minutes Mike uses. So the dependent variable that we're working with is how many minutes are going to be left if Mike uses it. The minutes depend on how many minutes Mike uses. So the dependent variable is whatever minutes are left.